2.4 Variables and Equations. The point of this lesson is for you to learn how to solve equations with variables. So we're going to start off with our first example. And here we have some verbal sentences. First step, we're going to rewrite our verbal sentences as equations. Second step, we're going to use mental math to solve our equations. And third step, we're going to check the solutions of our equations. So for the first one, we have the sum of x, and 6 is 9. Okay, so sum means addition. So then I can say this is going to be x plus 6 is the same as saying equals 9. So here's our equation. Second step, we're going to use mental math to solve our equation. What plus 6 would give us 9? So hopefully you figured out that that would be, so x equals 3. Now, whenever you get a solution to an equation, you must always check that solution back into the equation. So how do we do that? Alright, we're saying that x equals 3. Let's check to see if that's true. So here I have my equation. Now I'm going to check it. So I'll substitute that in. 3 plus 6. The question is that going to equal 9? And yes, it does. 9 equals 9. It's correct. You must do this step. Let's go on to the next one. The difference of 12 and y is 15. Difference, obviously meaning subtraction. The difference of 12 and y, because 12 was mentioned first and y second, that's the order we'll write it in. So 12 minus y is, meaning equals, 15. Here is our equation. Let's try to use mental math to solve it. So if we subtract a number from 12, we'll get 15. Usually when we subtract, the result will be a smaller number, but because it's larger, that would suggest that our variable must be a negative number, and that will ultimately end up adding. What could we add to 12 to get 15? We could add 3. So in order for this to work, 12 minus a negative 3 would ultimately become positive, because remember, to subtract is to add the opposite. So we'll say that y equals negative 3. Now you must always check to see if this is right. So let's go ahead and make our substitution. So 12 minus negative 3, will that equal 15? And so remember, to subtract is to add the opposite, and so it works. On to the next one. The product of negative 4 and p is 32. Product suggests multiplication. So the product of negative 4 and p is 32. There's our equation. Let's use mental math. What times negative 4 would give us a positive 32? Why is it not a negative 32? What was p to cause this to be positive? It must be a negative number itself. Alright, so a negative times a negative is a positive. So we know that it's negative. What times 4 gives us 32? That should be 8. So p is negative 8. Let's check to see, are we right about this? Negative 4 times negative 8. The question is, will this equal 32? And when we go ahead and carry this out, as it was discussed, negative 4, negative times negative is positive, so this would be 32 equals 32. And that's correct. You must check your answers. Last but not least, the quotient of n and 2 is 9. Quotient means division. So we'll go in the order. When you have a problem like this, because n was mentioned first, it'll be in the numerator. So n, the quotient of n and 2, dividing is 9. Mental math. What divided by 2 is 9? Half of what is 9? That would be 18. So n equals 18, and we must always check to see if this is correct. So, running out of room here, I'll move it over. 18 divided by 2, will that equal 9? And sure enough, this is how we check our answers. So it works. Okay, on to our next example, determining whether or not a value is an actual solution to an equation. We're trying to check for possible solutions. So Tell whether 9 or 7 is a solution of x minus 5 equals 2. In order to check to see if 9 is a solution, we have to substitute it in. So let's start off by writing the equation again, x minus 5 equals 2, and then we'll substitute 9 in for x. So 9 minus 5, will it? 9 minus 5 is 4, and 4 does not equal 2. This means that 9 is not a solution. That's the answer. And over here, again, we'll start off by writing the equation. Now we're trying to see, is 7 an actual solution? So let's substitute that in. 7 minus 5, will that equal 2? Hey, it sure does. 7 is a solution. Okay, third example. Now we're actually going to be looking at writing and solving an equation. An animal shelter charges $75 to adopt a puppy. 1 week they collected $1,500 in adoption fees. How many puppies were adopted that week? Let's start off by writing an equation. So the animal shelter charges $75 to adopt a puppy, meaning per puppy. Because the number of puppies controls how the cost fluctuates, we'll be multiplying that times x. So 75 times x, because it's 75 and x represents the number of puppies. So 1 week they collected $1,500 in adoption fees, meaning charging $75 per puppy. 1 week gave them $1,500, so we'll set this equal to $1,500. That's what happened 1 week. So we want to solve for x because they're asking how many puppies were adopted, and x represents the number of puppies. We got to solve for x. Could we use guess and check? Could we try to figure this out? Let me see. 75 times a number equals 1,500. Well, I know that 75, just put this over here for a second. 75 times 2 is 150. So how could I get that to 1,500? How about if we said 75 times 20? If I add an extra 0 there, I get to add an extra 0 here. So using mental math, we can still figure out that x equals 20, or 20 puppies. Got to remember the units. And of course, whenever you solve, you should always substitute it back in to make sure that it works. Will this equal 1,500? And when you multiply, you should see that it will.